So what we're looking at now is a big step in calculus, or the first big step, which is to talk about what's called first principles, which is what this thing here is. Basically, if you look back at the previous video, you'll see that we spoke about the average rate of change, which was just y2 minus y1 of x2 minus x1. And so that's essentially what we have here. If we look at these points again, we've got point x and then point x plus h. You can see that these are separated by a distance of h. And at the moment, h is 3.85. So, this point here is 3.5 to the right, 3.85 to the right of this point. And so what we're saying now is we're introducing this idea of limits. And a limit is this idea that as h, that we call it, so as this number goes to zero, so as this approaches zero, the point moves along the curve. And what was a secant, so connecting the two points and going through the 2 points was the secant. As these points get closer to zero, that secant essentially becomes a tangent at that point. Now you'll notice at zero, the line disappears, and that should hopefully make sense because you can't draw a meaningful tangent through one point. You need to have the points so close together that they're essentially zero, but not zero. So that's what it means to take the limit. So you can see here now that the gradient of this tangent is essentially the gradient of, this line at the point x, of this red line at the point x. And so we use this new notation. We say the limit as h approaches zero of f of x plus h minus f of x all over x plus h minus x. And you notice the denominator x plus h minus x is just h. So this is the definition of the gradient of any function across the whole function. And so we use this notation f dash of x. So we say that that's the derivative of the original function. So that's the process by first principles of finding the derivative of a function, also known as differentiating a function. You're applying this formula to it.